Before we hop into the code, I will show you an example of what binary search solves, to give you a better understanding of how it works. After that, I will show you step by step how to code it in Python. I'm thinking of a number between 0 and 11. You have to try to guess my number in the fewest tries possible. With every guess, I will tell you if your guess is correct or incorrect. Here is how that would go.
1,
Nope.
2,
Nope.
3,
Nope.
4,
Nope.
5,
Nope.
6,
Nope.
7,
Nope.
8,
Nope.
9,
Nope.
10.
Yep.
Now, as you can see, it took you 9 guesses to find the correct answer. If you had to guess from an array of 100,000 numbers, it would have taken you 99,999 guesses, which is not very effective. Let's try to find a number again, but this time with a binary search, to see the difference in efficiency. Again, I'm thinking of a number between 0 and 11. You have to try to guess my number in the fewest tries possible, but this time, with every guess, I will tell you if your guess is too low or too high. Here is how that would go.
5,
Too low.
8,
Too low.
9,
Too low.
10.
Yep.
Now, as you can see, it took you 3 guesses to find the correct answer. That's 1/3 of what it was before. If you had to guess from an array of 100,000 numbers, it would have taken you 19 guesses with binary search. That's a lot more efficient than what we did before. Now I will show you step by step how you can code a binary search algorithm in Python. So first, we have to define a set of instructions. We'll do this by defining a new function. The name of the function will be binary search, but feel free to call it whatever you like. We have to provide it 2 parameters. The first one would be the list that we want to search in, and the second one would be the item that we want to search for in the list. We can provide a small description of what the function is about, but that's optional. In order to find the middle element, we first have to know the lowest and the highest element. Index 0 of the list will return the lowest element. The highest element index actually depends on the size of the list, so we don't actually know that ourselves. We'll need Python to figure that out for us. We can do that by using the len function or method, passing the list to it -1. This will return the lowest index and the highest index. These 2 indexes will give you the lowest element and the highest element. We create a while loop because we have to find the middle element on each guess. The while loop has the following condition. As long as the lowest element is lower or equal to the highest element, keep the loop active. Eventually, the lowest element will be equal to the highest element, as shown in the previous example. But we don't want the loop to stop there, because we need it to return the value. If the loop stops, if the lowest value is equal to the highest, then it will never return the value. To get the middle element, we have to use the int method. Why? Because we need integers, we need whole numbers and not fractions of numbers. So 2.2 or 3.5 will result in an error because indexes are always integers. Remember order of operations. We first need to add the low to the high or high to the low and then divide it by 2. If we don't add these parentheses, then division will occur before addition, and that's not what we want. Now we can begin with the first check. If the middle element, and this is how you would retrieve the middle element, because remember, these 3 variables are indexes and not the actual values. This is how you would get the value. If the middle item of the list is equal to the item that we search for, we'll return the index, the middle index. You can make it return whatever you want, I will make it return the index. The next check would be if the middle item of the list is smaller than the item, then we know that everything before the middle item and the middle item itself, the current middle item, are not the correct guess, and we don't have to check that again. So our new low would become the middle item minus or plus 1. Why plus 1? The middle item has just been checked. Everything before that does not have to be checked. Everything after the middle item does have to be checked. So if we checked 55, then our new low would have to be 56. That's why we do plus 1. If it's not smaller, then it must be larger. So then our high would be our new middle minus 1. Why? Because if we check for 67, for example, and we know that it's bigger, then we don't need to check 61 again and everything above that. It has to be below that. So below 67 is 66. And that's basically how you make a binary search. Let's try if it works. I hope I got it right. We'll print the value of the binary search. We'll pass a list to it. Alright, remember that the list always has to be ordered. A list that would be like this would not work. It has to be ordered. So 1, 2, 3, 4, 5, 6, 7, 8, 9 is ordered. The value that we're going to look for is 7. Before I run this, it should return 6 in the console because it's 0, 1, 2, 3, 4, 5, 6. I hope it works. And it does work. It returns a 6. Let's try that again with a 9. The value I am expecting is 8. And it returns an 8. If I type 1, it should return 0. So that's how a binary search works. So this is basically in simple terms how a binary search works. I hope this video was useful and that you now know how to write a binary search algorithm in Python.